In this video, very straightforward, we are going to answer the question, what is an array? And let's just jump right into it. I'm going to tell you. An array is a collection of variables, all of the same type. The variables are accessed via an indexer, and the variables in an array are called its elements. All right, well, that was totally formal and not understandable, so let's look at an example. All right. So the way you declare a variable of type array, arrays are types, right, is you take the type of the elements of the array, let's say string, and you put a bracket. These are square brackets. So a pair of square brackets on the end of the name of the type. And so this now becomes the type of the variable, right? So scores is a variable. And what's the value of this variable? The value of this variable is a reference to an array of 5 elements, all of which are themselves string variables. Right? So this array has 5 values in it. These are the names of the scores in tennis, so love, 15, 30, 40, and game. And if I want to write those out, if I want to access the values of these variables, then I use the indexer, right, which is an integer inside square brackets. You'll notice this is exactly the same syntax as the string indexer that we've already seen. And then we can get the values of these variables out. Right? So let's just take a look at this in the debugger and see what happens. We step into here. All right. So a couple of things. You notice that over here in the locals window, scores has a little arrow here, right? And if I click on that, then I get the contents of the variable. So element 0 is love, element 1 is 15, element 2 is 30, and so on. Right? So that's very handy when you're debugging to be able to look at the contents of an array like that. Right? If I write out scores 0, right, you can see that we've written out to the console window love, 15, 30, 40, and so on. Right? So this is very similar to what we saw earlier, how you can fetch out the characters from within a string. You say, I want character 0, character 1, character 2, using an indexer. Arrays are just the same way. Right? You say, I want the nth element, and it hands it back to you. And also, just like strings, you'll notice, of course, that these are indexed by 0. Right? So the first element is element 0, the next element is element 1, and so on. And as I said with strings, there are kind of 2 ways to think about this. The first kind of bad way to think about it is every time that you're going to figure out which element you're talking to, you just either mentally add or subtract 1. Oh, I want the first element, so that's element 0. I'm looking at element 2, so that's the third element. That's the confusing way to do it, in my opinion. The way that I always conceive of it is the number, that is the index, is the distance from the first element. Right? So how far away is the first element from the first element? It is 0 away. How far away is the second element from the first element? It is 1 away, and so on. Both ways of doing that are correct. I just find my way to be less error-prone when I'm thinking about it mentally. Because, as I said before, very common in computer programming to make an error where you add 1 where you meant to subtract 1, or where you forget to add or subtract 1. Off by 1 or off by 2 errors are super, super common in programming. All right. So here's a question. What happens if I try to get the 5th element from this array? Well, or should I say the 6th element? Because I'm going to try to get array element 5, the one that is 5 away from the beginning. Well, this thing only has 5 elements, so this should be fetching the 6th of them. And so if I do this, then once again we have an exception. You remember that in the previous video we saw that we got a formatting exception when we tried to pass something that was not a number string to int.parse. This exception says index out of range exception was unhandled. An unhandled exception of type index out of range exception occurred in this executable. Additional information, index was outside the bounds of the array. And that is certainly true. Right? The bounds of this array are 0 through 4. We tried to access an element that was outside of those bounds. And the runtime produced an exception when we tried to do so, saying this program has a mistake. You should basically just never do this. Right? Don't if you learn about exception handling, as you eventually will, we're not going to cover it in this course, you never want to handle an index out of bounds exception. You always want to avoid it, right? It's totally avoidable. You know how many elements are in this array. Don't ask for the element. Don't ask for the sixth element when there are only 5 elements. Right? So here's a question. How many variables are there in this program so far? There's actually 6. There's scores, which is a variable of type array of strings. And then each of these elements, 0, 1, 2, 3, and 4, indexed, are themselves variables. And we can prove this because we can actually write to them. Right? So I could say here, scores 0 equals 0. And now, if you notice we don't get any red squiggly. This is a perfectly legal program. And now if we step into this program, you can see here, this guy starts off as love 15, 30, 40 game. When we execute this statement, you notice this is in red highlight, indicating this value just changed. If you were not expecting that to change and you suddenly notice a little flash of red off in the corner, that can be your hint that maybe your program has a bug, or maybe it's doing exactly what it's supposed to do, but something just changed. All right. There is a length property on strings that we saw before. And just like that, there is also a length property on arrays. And it is a read-only property, right? So if we run this thing, step over that, we can see scores.length. We can hover over that, and it's equal to 5. So now that we know that arrays have a length property, we know that the first element is 0, and we know that the last element is the length minus 1. Because the indexers go from 0 through the length minus 1. We know that we can use a loop, right? So suppose we wanted to loop through each element of this array. Well, that's totally straightforward. We would make a variable called index, let's say, set it equal to 0. The condition of breaking out of the loop is that the loop body will only execute if the index is less than the length, right? Because remember, again, we just saw that if the index was 5 and the length of the array was 5, it's going to crash, right? We only have 0 through 4. That's 5 elements. Okay, so the index has to be less than the length of the array. Every time through, we'll increment the index by 1, and then we will just write out the scores. And as you would expect, that is exactly what happens. Right? So we have indexed each one of these things by the index that is constantly increasing. And when index is equal to 5, we don't run the body of the loop because the condition is now false. Now we step out of there, and we can take a look at our slide here. We've written out 0, 15, 30, 40 game. I mentioned in a previous video that there's a special kind of loop called a for each loop. And for each loops are even more tailor-made towards arrays than for loops are. The way a for each loop works is you say for each, and then in round parentheses, we have this. We have a type. We have a variable name, right, that I've called element here. We have the keyword in. And then we have a collection of objects, in this case, an array. And of course, the loop has a body, which is a statement. The type is the declaration. It's either a type or var. The element is the name of the loop variable. The collection is any expression. In this case, it will always be something that is of array type. And the body is a statement, right? So what's the difference between a for loop and a for each loop? Well, the difference is there's no indexer here, right? What this thing does is it says, do it as though you were doing a for loop, and every time through you were pulling the value of the next element out, going from 0 through to the last element in the array, and just stick that into this variable score, right? So you notice that the mechanism here is a lot simpler, right? Up here in the for loop, we are messing around with this index. We're saying, OK, we have to have an index. It has to go from 0 to the length minus 1. We have to increase it. The for each loop just says, what's this array? It's a bunch of strings. All right, well, give me each one in turn and run this body given the different value of each element as we go. Right? So let's just step through that. And you'll see what happens is, first we say, what is this expression? We evaluate this expression once, only once. Right? Now this is a little bit weird. C# highlights the in, and basically what this is telling you here is this is the point where the runtime, where the language is trying to figure out, is the loop done? Right? This is where the condition would be if this were a for loop. Right? Now it's saying this is the bit where score is being assigned the next value in the array. Right? And what's it become? Score has become 0. We write that out. Step over that. Now we go back to the in. Right? So now it's figuring out, are there any more elements in this array? Right? Well, we've just printed out the first one. There are 5, so we're still going. Right? It makes score have the next one in the array. So it's now 15. We write that out, and so on. Right? So this is a very nice, clean, abstract way to write a loop. It's my preferred way to write loops, because I would rather not mess around with all this mechanism of indexers and trying to keep track of them and making sure that they're incremented correctly and all of that. I just want to say, I want to do something. I want to have an effect on each element in this array. All right, so one other thing that I wanted to mention, I glossed over something at the very beginning. Right? Up here I said we've got this variable called scores. And then, of course, a variable has an initializer. Right? We've seen that many, many times. And I just said, oh, I'm going to put in some braces here, and I'm going to put a bunch of strings in here. And I never really explained what was going on there. So basically, this syntax means I want you to create me an array with this many elements. Here are the elements. Just figure it out. Right? Now, you might think, well, this must be an expression. Right? Well, it turns out that no. Though this kind of does appear to have a value, C# does not treat this thing as an expression. This syntax is only legal in a variable declaration for an array. And you can see that down here. I've got an example here. I've said I've created an array, this time of integers, not of strings, called ABC. And I've initialized it with the numbers 10, 20, and 30. Great. Now, if I create an array variable called DEF, and I try to initialize it on its own line with this thing, then I get lots of squigglies here saying that this is unexpected. What are you doing? I don't understand it. I kind of wish that C# would give a better error message here. I wish it would say, hey, it looks like you're trying to use an array initializer, and you're only allowed to use an array initializer in the initialization of a variable. So this is not legal. However, this is legal. Right? So this is how we would do this, not inside an initializer. So we say new. We've seen this before. We saw this when you were creating date times. We say new, and then the name of the type. Right? So array of integers, and then give the initializer. And this informs C# that, oh, what are we doing? We're creating a new array of integers. Here are the elements. And there's a lot of different variations on this syntax, and we're going to look at those variations in a later video. Summing up, what's an array? An array is a collection of variables. The variables are all of the same type. It's accessed with an indexer starting at 0. The array has a length property. The length property is read-only. And so arrays are fixed in size. Once you've created one, it's always the same size. You can use the for or for each loops to iterate over all of the elements of an array. You typically, with a for loop, would have a loop variable that is an index that goes from 0 up until up until length minus 1. I prefer to use a for each loop because it gets rid of all of that mechanism. You can just say for each element in the array, and the loop will fill in the loop variable with each successive element of the array. You always have to access arrays in bounds. And that's actually one of the reasons why I love the for each loop, is the for each loop guarantees it will never go outside the bounds of the array. Whereas you could see it would be quite easy to make a mistake with that for loop. You could get the indexer wrong in some minor way that would cause it to go out of bounds. You can use new int or new integer array or new array type of any kind of element type to create a new array outside of an initializer. Right? And you can use this more concise syntax only within an actual initialization statement.